Hello. Today we're going to be talking a little bit more about regressions. We're going to kind of step away from linear, though, into the world of quadratic and exponential. So, first things first, you are going to want your graphing calculator out for today. And that is actually the first thing that we're going to go ahead and do. So, if you open up your graphing calculator, we're going to be entering in everything in this table on the right hand side. So, first, let's see what example we're really working with for today. So this says a pumpkin tossing contest is held each year in Morton, Illinois, where people compete to see whose catapult will send pumpkins the furthest. The table shows the angle at which the pumpkins are launched and the corresponding distance achieved. So the first thing that we are gonna be looking at today, obviously, is we're gonna be looking at the correlation coefficients for each of these three types of regressions. Now we did our linear regression yesterday. Today, though, we're also going to be looking at some quadratic regressions and also potentially some exponential regressions. And the correlation coefficients that we're going to use either range from either r or r squared. For our linear regressions, these specifically, we're always looking at the r value. For quadratic and exponential, this is actually what we use the r squared value for. So what we need to do first is obviously pull up our graphing calculator. So I have mine here. And we're going to obviously start by going into the stat menu, the edit menu, and we're going to type in all of the values from that table into our calculator here. So what I want you guys to do is pause your video and type in your values now. All right, I have all my values typed in. Now, before I actually find my regressions, what I'm first going to do is I'm going to go up into my stat plot, and I actually want to see what a picture of this looks like. So if I go in my stat plot, I just want to double check that my scatter plot is selected. And now I'm going to hit zoom 9. And I can kind of start to see, I'm a little suspicious that our type of regression, we want to think about which graph most closely resembles the one that we're working with. So if you will remember, each of these kind of three different types, obviously they all kind of have their own shape to their graph. If we're going to be looking at a linear function, all linear functions, all of your points are obviously going to look somewhat like a pretty straight line. If you're going to look at your quadratic functions, all of these are going to have some sort of U-shaped graph. And all of our ones that have exponential shaped graphs, these are all going to look something like this, where they start off pretty flat and then they go up, or they start off pretty flat and then go down. So whatever graph we have, we can kind of tell from this picture that most likely this is going to be our quadratic regression. Now, you can also use another feature, which is a little more accurate, which is the R value. So if we go into the stat menu, I'm going to arrow over to the calc menu. First things first, we're going to do what we did yesterday and calculate the linear regression. And let's just see what the line of best fit actually was here. Well, if I look at my R value here, not R squared, we're looking at R for the linear, we're going to get a negative 0.23, or excuse me, 0.234 if we round correctly. And that is a pretty weak correlation, verging on no correlation at all. And that kind of makes sense because my points don't really follow a linear pattern. So what we're now going to look at is our quadratic and exponential. And it's actually in the same list. So if I go stat calc, the next one we're going to look at is the quadratic regression, which is option 5 on your calculator. So if I click enter, again, click enter until it calculates. Now here my R value is pretty darn perfect. My R value is about 0.999, which is about as close to perfect as we can get on this one. So that makes sense because that's kind of the direction that my points were going in. Now, for my exponential, we're back in that same menu, stat calc, and we're going to go down to exponential, which is option 0 on mine. So if you click exponential function, and again, enter down until you calculate it, we can see that if I look at my R value here, my R squared value is 0.07. And actually, guys, I think I might have used the wrong one on my last one. For the quadratic regression, remember quadratic and exponential, we use the R squared. Oh, and that one was this one. Okay, cool. So if I look at stat calc 0, let's go back to my exponential. And here I'm looking at the R squared value, and it's even worse here. We have 0.07. This is probably one of the farthest R values away from exponential that we could possibly find. So when we choose the function that is going to fit our graph, we want to choose the one that has the best R value for the job. So for R's, the one that has the strongest R value is going to be our quadratic regression. And this is where we're going to use our calculator to actually write down that quadratic regression, because that's the one that had the best fit. So our quadratic regression, obviously for part B, that's why we would choose our quadratic, because it has the strongest R value. It has the strongest R squared. Those are used pretty interchangeably when we speak it. So the strongest R value. All right. Now, so when we get to the actual equation, we're going to just copy down what our calculator gave us. And it says y equals ax squared. A in this problem is negative 0.26 x squared. B, it tells us, is positive 22, so plus 22.59. And then our C value plus 23.03. This guy is our quadratic regression for this. And now once we have our equation, now all bets are off. Now we can answer all the questions that we kind of see down below. So for here, it says, using your equation, what is the predicted distance of a pumpkin shot at an angle of 54? So here I know for a fact I can now calculate it. I'm saying if my angle is 54, which means I'm going to be plugging in 54 in for x, and we're going to solve. So y equals negative 0.26 times 54 squared plus 22.59 times 54 plus 23.03. And if you do type this into your calculator, you're going to get, it all simplifies down to 484.73, which as our final answer, then we do want to make sure we include units with our final answer. It ends up being 484.73 feet. Okay. So if you guys want, I want you guys to pause your video and you guys can give example 2 on the back page a shot. All right, final answers are up. Now this one, if you didn't finish this whole problem, I probably know why. Because if you actually calculate your R values for both the quadratic regression and the exponential regression, you do get some R values that are really similar. So if you look at the graph, usually if your R values ever are super close, we almost always look at the graph to kind of make that final decision. And if you would have on your scatter plot, I didn't make you guys graph this, but it followed kind of this sort of pattern, which could be a quadratic, but it most closely resembles that exponential. That is what all of our exponential functions actually end up looking like. So yeah, it could be a quadratic, but if you can't tell based on just the R value, usually we go with what the graph most closely resembles. So unless it's starting to kind of come back up and form that U, most likely it's more kind of fitting that exponential regression curve. So that's why this one, even though there was kind of a tie with that R value, we would choose the exponential because of the fact that that's what it most closely resembles, is the exponential graph. So that's why for this one, our exponential regression, you should have gotten your A value to be 8.46. And what goes inside ended up being 1.42. And then for question D, it just meant that it says, what is the predicted number of scooters sold in year 12? So obviously we're saying what happens in year 12, and we are solving for the missing value, which was about 568.63 scooters. Okay. So you guys can now pause your video and you guys can give the homework on the other page a shot.